All right, thanks guys. Thanks everyone for coming. I'm Yorke. I'm part of the engineering team at Hyperlane, and today we're going to talk about permissionless interoperability and what that means. If you have questions afterward, or if you want help with integrating Hyperlane in the hackathon, definitely come up to our booth, or you can ask me questions at the end. So just to start today's session, I think we need some definitions of the title slide. So permissionless, I think a lot of people throw that term around. It's kind of at this point used for marketing, but generally the word permissionless means that a protocol is accessible to anyone. There's no kind of discrimination or censorship for specific classes of users to access a protocol. And interoperability, I think our definition that we can use today is composability for applications that are on different infrastructure layers. And so, the internet is highly interoperable because we have all these shared protocols that are quite permissionless. We have, HTTP, TCP, etc. And in Web3, we're just starting to establish kind of these shared standards that allow applications to communicate with each other. But the problem we see today is the crypto space is facing this scalability problem. And people have kind of identified this as the barrier to adoption for the next, billion users. And, there's all these great teams at hackathons like this building out these new scalability solutions for, to onboard that next set of billion users. But the problem is we're ending up with these kind of highly divergent infrastructure layers that don't actually use shared protocols to communicate with each other. And that leads to a big problem. I think if you look at the evolution of crypto, we've continued to diverge with respect to what protocols we use. I think maybe the first decade was just Bitcoin payments. It's a very simple application. And then we kind of evolved to these smart contract VMs, and that got a little more complicated. And we saw Ethereum and Near and Solana all popping up with different protocols. And then some people got excited about app chains because there's different scaling properties that you can have if you don't opt into this monolithic infrastructure layer like Ethereum. Or recently we're seeing Ethereum kind of coalesce around the roll-up scaling roadmap. I think Vitalik had a seminal blog post about that. Arbitrum and Optimism now do more daily activity than Ethereum L1. And these protocols also kind of have their own new standards. There's these new DA layers that are in service to those rollups. So we have Ethereum 4844. It's this EIP that kind of changes the cost structure for posting call data to L1. We also see Celestia. It's this new modular DA that maybe app chains can post call data to. Again, a lot of different kind of diverging protocols. Maybe in the future we'll see some sort of plasma or sharding solution. I think there are probably some teams here working on that. I don't know what happened to my slides. Oh, there we go. But yeah, this is a problem. On the flip side, at the kind of looking at this from an application perspective, we're seeing a lot of dApps actually adopt these new infrastructure layers, which is super exciting. So actually just a couple days ago, Zora, which is this big kind of NFT social feed and explorer application that is one of the most popular applications on Ethereum, announced that they're going to be rolling out their own layer 2 using the Optimism OP stack. I think you guys have probably heard of Coinbase's efforts to work on their own L2. They launched Base testnet I think maybe a month or two ago. If you look at this website, L2Beat, you can see kind of the evolution of activity over time across these different infrastructure layers. And what you'll see is that actually, a majority of activity has migrated to L2s. And so we need a way for these applications to, communicate with each other. And the problem today is we have a highly fragmented market. So we have Arbitrum, Optimism, kind of the two main leaders. I would say ZK Sync, it's like the fast follower. They launched the first Validium, so people are super excited about that. And as an application developer, when you're choosing what rollup to deploy your application on, it's a really hard choice because you have to think about what's the security story of this specific rollup. What does the current ecosystem look like? Is there enough liquidity? Are my users going to be stuck here if the platform decides to change their, terms of service, or maybe they're going to censor users based on like OFAC or something like that. It's a really tough choice. There's all these different interfaces for interacting with these things. So for example, Arbitrum, Optimism, ZK Sync all have different smart contract interfaces for handling deposits and withdrawals from L1 to L2, moving assets between different L2s. There's kind of also highly fragmented like bridge solutions. So depending on what applications are where, there's different bridges available. And then more recently, we're seeing these kind of general message passing protocols to move arbitrary information between L2s pop up. Hyperlane is an example of this. But again, there's just like all these things to account for. And as an application developer, you have to kind of know about all these interfaces, and you have to custom integrate every single one of these like new rollups, new infrastructure layers. And that's just like a really bad place for us to be in. Actually, just this week, Vitalik posted about this, so like super topical. Vitalik's like all in on rollups being the layer that applications should build for, and he wrote a blog post about kind of what the solution space looks like for interoperability between L2s. And I highly recommend this post. I don't know what's going on with the connection here. Yeah, highly recommend this post, as well as the 3 transitions post, which talks about kind of this like evolution of scaling solutions, and how we can actually, get users to like adopt these things in a way that's internet scale. But yeah, what's the solution to this problem of like fragmentation? We think at Hyperlane, we think it's modularity. You may have like heard the term modular blockchains. It's like also a heavily used marketing term at this point, but the main idea is you want to like separate the interfaces which are exposed to applications from the actual like underlying transport layer stuff. So, if we have all these rollups that have different kind of like security properties, I think the 3 kind of examples we can work with in our head are like Arbitrum, Optimism, and ZK Sync. All of these rollups have very different kind of security stories, like when you can view them as settled, what the finality looks like, can you use like soft confirmations, etc. And as an application developer, like you shouldn't have to think about that or like custom integrate that. So instead, we can have this like universal interface that looks like a message passing interface. And under the hood, depending on the path that we're taking, we can actually leverage different underlying transport layers. But the application developer shouldn't have to necessarily understand that. There should just be kind of like a community governed set of standards for like, okay, if we're going from, L1 to Optimism, we're going to use this specific transport layer, which is like the Optimism bridge to collateralize my deposit. But again, like the application developer shouldn't need this crazy like switch case statement of like, if this network, do this specific function call. So that's where Hyperlane comes in. Hyperlane is this kind of like universal interface that tries to abstract all these different bridging interfaces through like what we call this like general message passing interface. And so as an application developer, all you need to understand is like this dispatch interface and this handle interface. So I can walk through kind of the life cycle here, but your smart contracts or your EOA for that matter can call into this interface called dispatch, which basically specifies the destination blockchain via like a chain ID, a recipient address on that destination chain, and just like an arbitrary body of bytes, raw bytes. And behind the scenes, our protocol will handle the transport layer stuff. And then on the destination chain, basically the handle function will be called on the recipient that you specified. And that will also provide the like origin chain sending address on that origin chain and the body that sender sent. And now obviously, like as an application developer, you want kind of strong guarantees around the content and kind of like validity of, messages that you're receiving or messages that you're sending, that they're actually going to get delivered. I'm happy to kind of talk about the different guarantees that we have for different pathways. But generally, like, because this is a hackathon, I think it's like better to sometimes avoid those like, nuanced discussions of like what the security trade-offs are, and just try and build something which is useful or like demonstrates a new use case. But yeah, the idea again with modular interoperability is like, as an application developer, we actually have this interface where we allow you to configure your security preferences and your risk tolerances. So we have this like interchange security module interface that as a message recipient, you actually just configure as an address if you opt into this like configuration layer. And the idea is when you're receiving a message, our protocol will ask you, hey, what is your security module mechanism of choice? We provide a bunch of off-the-shelf components that you can kind of like select from and compose for the various channels. So like, optimism, canonical bridge, or, using wormhole or whatever it is. Our protocol will ask your application what security module you've configured for this specific like origin and sender and body. You can actually have control flow on the message body, which actually changes the security requirements. And so an analogy there is like wire limits in traditional finance. Like if you're just transferring $10 across, two chains, you might not care so much about, the guarantees that you have in your application, and you might not want to pass those costs on to your user. But if it's like $1 million transfer, or if it's like some sort of governance action, then you might want to like really ramp up the verification requirements. So this is like, yeah.
Modules that just generally.
Yeah, so it's sometimes it's which bridge do you want to take. We think that like, bridge is like a loaded term. So there's also different flavors of security. You can opt into like economic security versus like reputational security. Or you can have like certain, I don't know why this keeps dying. So for example, our default security mode for a lot of pathways is this economic security mode, where we have a set of validators who are staking on the origin chain, and they're producing these attestations of messages which are being sent from that chain. And as a recipient of messages from that chain, you can say, I want to leverage like this economic security, which gives you a like discrete cost to attack the system, and kind of it gives you a lower bound of like, hey, up to this, or I guess an upper bound, up to this economic value on this specific message, I have like kind of strong economic guarantees that this message was actually sent from this chain. Because otherwise, like the validators will be slashed. It's kind of economically irrational. And so that's like one type of guarantee you could look for. Alternatively, you could have these sorts of like, like if you're using a canonical bridge, you have this like fraud-proof system where you can always like kind of do forced inclusion or those sorts of things. But economic security is not the only mode. We can do like an optimistic security model. which is like a very different trade-off. And it's actually like you can think about it as like operating over the same bridge or the same tunnel, but just like the security constraints that you're imposing on that bridge are actually look very different. Yeah.
I'm not sure if that is already, but where is that?
So right now we just have like, right now it's like a whitelist, but we're like really soon hoping to transition to a fully permissionless like validator model where you can put up any staked asset. It actually doesn't matter what asset it is on the origin chain. And you're basically just like producing attestations. It's kind of super easy to run because there's no consensus and the validators are not networked with each other. They're just producing attestations on messages that are being sent outbound. Just need like an RPC connection to a chain. Depends on the chain. We have all the information in our docs if you want to check it out. Yeah. So yeah, the last thing I want to highlight is this, I guess, modular security paradigm allows you as an application developer to eliminate this like scary choice of being locked into a specific bridge or a specific security model or pathway for your users, because you can configure this. And so in future, if some sort of like ZK Lite client becomes available for some pathway, you can just configure that later on. This is kind of like a way for you to, again, separate the application layer from the transport layer. And we think this is like really important for just like application developers when they're reacting to kind of the evolution of all this infrastructure. They shouldn't like impose those things on their user. They shouldn't have to tell their entire user base, hey, we're actually migrating bridges, so you got to go and like unbridge and then rebridge and then like migrate to our new version. Like that's crazy. So this is just like kind of the model that we think is better, and is really a framework for how to think about interoperability. We obviously have like specific opinions about like what the default security modes should be. And if you don't, as an application developer, if you don't specify like your own preferences, you will kind of by default be opted into our preferences. But yeah, that's the like modular framework. The last thing I want to highlight about this like modular security paradigm with Hyperlane is you can deploy Hyperlane anywhere. So we have a guide right now in our docs that like walks you through all the steps. Right now, it's only available for EVM networks, but we have several other environments that are pretty much like production ready. We're running on testnet on Solana. We have a Fuel VM implementation. We're working on a Cosmos SDK module. And so really, we want to make this protocol and this framework available everywhere so that you as an application developer, not only do you not have to choose a specific bridge, you don't even have to choose a specific execution environment. If you're worried that, later Solana might become might eat up all the DeFi market share or something, Hyperlane allows you to easily have your application exist across all these execution environments. And maybe in kind of the near future, your users don't even know which environment they're running on. Because they just have like this single interface into your application, and you decide where it makes the most sense for them to get routed to. But yeah, the specific kind of thing I want to highlight here is now if you want to spin up your own rollup, which is kind of, I think, like we saw earlier, something that a lot of people are thinking about. There's this kind of traditional problem of like, okay, you've spun up your rollup, but like it doesn't do anything because it's not connected to anything. There's no bridges operating to it. There's no liquidity, etc. And in the past, if you wanted to, make those connections to existing ecosystems, you have to go out and you have to talk to organizations and kind of do BD and establish trust and ensure that the bridge that you're getting to come to your ecosystem isn't risky for your users and isn't gonna just rug you or something. And now that you can deploy Hyperlane and you can configure your own security, you don't have to do any of that. You can start as a new rollup. You can operate your own deployment of Hyperlane, and as you scale up and as you kind of progressively decentralize, you can continue to configure the transport layer with stronger and stronger like security guarantees for your users. But to start out, it doesn't really make sense for you to impose those requirements. Like you don't want to, before you launch your rollup, you don't want to require that there's like a full like client implementation across like a bunch of different clients or something. You just want to like be able to launch your application, test it, iterate. So yeah, we think this is like a big, yeah.
Do your deed with
That's a great question. So that's probably one of the biggest things that you need to understand when you are kind of building for this multi-chain future is the introduction of like asynchrony and execution across many chains definitely introduces a lot of complexity. And one of those complexities is we don't have strong guarantees of transaction inclusion, at least today. So unfortunately, like the way our protocol works is you pay a fee on the origin chain, which covers the gas costs on the destination chain of like transaction inclusion. But, if that destination chain's validator set is like deciding to be mean or whatever, they can just like censor you. And then your Hyperlane message won't get processed. In future, we have ideas about basically like building Hyperlane messages into the block proposer like auctions themselves. So like we could have, block proposers like potentially an eigenlayer set being aware of Hyperlane messages that like want to be included for a specific block. And like, we can have a more sophisticated fee market for like message inclusion. But right now it just falls back to basically like transaction inclusion, which is not something we have guarantees about today. So even as a user on a single chain, when you attach a fee to your transaction, like you don't have guarantees that it'll actually get mined. It's just kind of like an assumption we make based on like, the market dynamics.
Yeah, like when you call it up or share, you can cancel the transaction from the user data cancellation cost.
That's a good question. So we don't have a native concept of cancellation or timeouts or ordering or anything like that. Like the core protocol is kind of very unopinionated in that respect. But there are middlewares that you can like opt into, which can kind of introduce, like basically timeouts or cancellation semantics to messages, with the trade-off being that you like lose out on some composability because now applications need to understand that like, hey, there's this header attached to messages, which, defines some timeout or whatever. But yeah, that's a great question and something we honestly like, I think should think more about. So just to give a few examples of kind of like the developer primitives and tools that are available on top of this protocol for you guys to use, that are maybe like less intimidating than just this like raw bytes pipe between chains. We have like this warp routes abstraction, which is like, should be familiar. It's like similar to traditional token bridging, where you can, basically just like connect either canonical token or native token to a bunch of synthetics on a bunch of chains. Again, the kind of modularity of Hyperlane allows you to evolve and configure the security of this warp route. So you could, just as an example, which we've talked to with a lot of customers, or like a lot of customers are excited about this specific example of like having application-specific security. So if you're transferring on a warp route, more than, let's say, 25% or 50% of like all of the circulating supply on that chain, you might want some like administrator in your application to actually like function as a notary or a veto or something, just to ensure that like, you know, your application didn't get rugged by like some bridge. And with the interchain security modules, you can like totally do that really easily. So you can have these different like safety modes. We just actually sent the first like token transfer between the Solana DevNet that I mentioned earlier and the EVM. So that's maybe something you can play around with this weekend. We also, like I said, have been expanding to other ecosystems. So if you guys are interested in like kind of some of those longer tail ecosystems, definitely be happy to chat. But yeah, this is just one abstraction. We also have this concept of interchain accounts and interchain queries, which again is like an API that as a developer you can use, kind of simplifies some of this like cross-chain control flow. So interchain accounts are basically a way for you to have a contract on one chain, own assets, or do actions atomically on another chain. So basically, if you're familiar with the concept of like a smart contract wallet, this is like smart contract wallet for your contract on another chain. You can basically, your contract on the origin chain can like send calls to be proxied by its interchain account on some other chain, and you can send assets to your interchain account. We think this is pretty useful, especially for like DAOs. If you want to give ownership to some DAO that exists on another chain, you can just do that counterfactually without the DAO even like opting into it. You can just be like, hey DAO, like I'm giving you this permission to your interchain account. Come and, you know, take me or whatever. And so, yeah, this is kind of a powerful primitive for just managing assets on different chains. You can do like some sort of multi-chain portfolio management type thing without actually bridging those assets, which is like sometimes risky. And then the Interchain Queries API allows you to basically make like cross-chain view calls. So you can like, you know, go query a contract's function on some other chain. Some examples of using this have been like looking up ENS ownership or NFT ownership on Ethereum, because like there's a lot of, I guess, network effects on Ethereum L1, but people want to migrate their application ecosystems to other chains. So this is a way for you to kind of have remote views into other chains' state and networks. And that's it. I guess I'm almost at time anyway. Can't really do the demo because my Wi-Fi has been really struggling, but I would love for you guys to check out our docs. We have a message explorer with an API. We have $10,000 in prizes this weekend. So, you know, big opportunity if you just want to like use one of these APIs. You could deploy Hyperlane to one of these new chains. You could try deploying Hyperlane to Zora or Base or one of these new rollups, and have your application do something cool with that. I think we're also looking for people to use warp routes. If you use one of these APIs, interchain accounts, interchain queries, I'm sure that would qualify. So yeah, that's it. Thanks for coming.